Okay, let's get started. Welcome, Somase. She's from TCS Research. Yeah, over to you, please.
Thank you, Jyoti. Hello, everyone. Myself, Akanksha Somase, and I'm from Tata Consultancy Services. And I'm going to present a paper on accelerating software development using generative AI. So, basically, I will discuss motivation behind taking up this work, the solution approach that we used in our paper, and lesson learned along the way. So basically, what is the motivation was, as we all know, that software development life cycle produces, in this process, we produces a distinct engineering artifacts. And for building these artifacts, we required SMEs, which has a relevant skills specific to that phase, right? So eventually, the quality of deliverables is also going to be dependent upon the skill of SMEs. As we know that generative AI has a significant influence on the software engineering task. It can help us to lower the SME skill barrier. So as we know that these LLM models are trained on large corpus of data, they have has this capability to understand the natural language text. So SME can operate it on natural language text, and eventually we can save time and effort for the skill development team. So basically, this was the overall motivation. Then what are the key contributions? Our key contributions in this paper. So we use the power of generative AI for generating a distinct engineering artifacts that we produce that we build in SDLC. Next contribution was that we designed this template, a generic prompt template for each phase of SDLC based on the high level meta model to provide it a structure. And we also evaluated our approach on this state of art model, that is ChatGPT, and we validated our approach on this small yet complex enough application, which I'm going to discuss in upcoming slide. So the picture that you are seeing on this slide is nothing but a high-level meta model that we use for designing our prompt template. This prompt template was very helpful for a successive refinement approach that we used in our method. So this SDLC meta model is composed of three parts: a requirement specification meta model, design specification meta model, and code generation meta model. So requirement specification meta model cover concept such as context, processes, activity, parameters, rules, rule type, and different association among these concepts. So context is implemented by processes. Processes are described using activity. Activity may have sub-activities. Also, activity have some associated input and output parameters with it. Processes has rules, may have multiple rules, and each rule is categorized into rule type. This is the requirement specification meta model. Now come to design specification meta model, covers the concept related to presentation, service, and data layer. Within presentation layer, it include concepts such as user interface screens, user interface classes, buttons, attributes. In data layer, we have entities and relationships. And in service layer, we have services and operations. The button of presentation layer invokes the operation of service layer. So this is the association among these two different components. Come to code generation meta model, it covers most all of the concept that comes under design specification meta model, and additionally it includes concept like a operation like classes and attributes. So this is all about the meta model. Now coming to our approach, this is the step-by-step methodological approach that we use for developing the application. Uh, this step, this the, this approach that we used, we have different steps mentioned here, and it uses this successive refinement approach, as well as we have used this prompt templates which are generic and designed based on the high level meta model that I have explained in previous slide. So starting with business requirement, we have to collect the business requirement. User have to provide it to the LLM itself. So within the requirement specification generation step, we generate SDLC artifacts such as processes, activities, parameters, and rules based on the input business requirements. In design specification generation step, we generate design specification details such as screen, fields, entity relationship, and all. And it is based on the requirement specification provided. Code generation layer generates the code for user interface layer. It generates the service layer code, business logic, and DB scripts coming to based on the design specification, of course. In test case generation steps, we generate different test cases along with the test data for unit test cases, system test cases covering different functional and unit test cases. All these steps are executed on the LLM session, can be executed in separate LLM session for different domains, and they are using space-specific prompt templates which are designed based on the meta model. So, prompting strategy, there are several key aspects of our prompting strategy that we used. It covers like the prompts, which I already mentioned that prompts are designed based on the high-level meta model to provide a structure and also to describe the association between different SDLC artifacts. Next, that we come up with a phase-specific prompt template for each SDLC phase so that it can be executed in a separate LLM sessions. The first prompt of each prompt generic prompt template is going to be prompt for setting the initial context to set for the subsequent generations. We design a prompt which cover the high level, which include the type of rules, 9 type of rules in the prompt itself. Within the design specification layer, within the design specification prompt, we come up with a strategy, 2-level strategy. We first generate description for different screens and services, followed by the detailed generation, which include the comprehensive design. And in the code generation prompt template, our strategy was to generate a code corresponding to single file so that it will eventually reduce the manual copy pasting effort. So this is what a generic prompt template will look like. This prompt template are domain agnostic and application agnostic. It takes the requirement specification prompt template takes domain, context, and business requirement as an input. The business domain covers the specific business needs such as pension scheme, insurance, banking. The context is something that is related to additional details related to operating market and geography, and business requirement specifies the overall scope of application. So the first in the requirement specification generation prompt template, we have it covers the prompt related to generating processes and rules. For process generation, we cover the activities and processes in the prompt itself. If you look at the second prompt, and in the third prompt, that is for rule generation, we find the rule types in prompt itself that I have already mentioned in previous slide, I think. So the rule types are like access control rule, business logic rule, calculation rule, data validation rule, display rule, and all. So also all these generated responses are validated by SME for accuracy and ensuring accuracy and correctness. And if any accuracy is observed in the generated response, are corrected by providing the edit prompts for necessary updates. This is the next. This is a prompt template for a design specification phase. Similarly, here this step takes this template takes business domain, process and rule specification details as the input. The process and rule specification details are taken from the response generated in the previous phase, that is the requirement generation. That's why it is mentioned there that the requirement prompt to response, it's going to replace the placeholder here. Similar for this rule specification. The first prompt is for providing the initial context by using the input. Second prompt is for generating entities and relationship description. From third prompt onwards, we apply our strategy to first generate the high level description and then go for the details. Like here in the third prompt, we ask it to generate the service description, and getting those description, we generate asking it to generate a message signature along with its input and output parameter. Fourth prompt is going to execute for each service that we have received in the third prompt. In fifth prompt, we ask it to generate the high-level description for different screens, and in the sixth prompt, we generated further details such as UI classes, attributes, buttons for each screen that is generated in the fifth prompt. Now, application code generation template. This template takes business domain, technology stack, entity relationship details, and service specification, along with the screen specification details. Here, entity, service, and screen specification details taken from design specification phase, and technology stack specifies the technology of interest that where we want to build our application in. The first prompt is for setting up the whole initial context, which include the application architecture. Where here we have to replace the actual technology stack with the placeholders as well. After setting the context, we generated the service layer code, which followed by the data access object class code and input output class code. Again, after validating the code, we generated code for the screens, which cover the code for screen layout with code for screen validation and for handling the events. Similarly, the code for database schema is generated for each and every entity present within the entity relationship specification that we received in a design specification phase. And then again, code is checked for compilation and compilation errors, if any, and those errors are resolved manually. Uh, Similarly, we have another template for test case generation. So the inputs are somehow similar to the somehow similar to the design specification. Here we are also taking the service and specs for setting up the context. Within initial context, we passed it the and next for services, we generated test cases along with of test we want to generate, which include a functional test cases, data validation, exception handling, and then we generated screen-specific test cases covering test case types such as screen flow navigation, data validation, and also generated the test data for those test cases as well. And at the end, we generated a system test cases uh, to test the overall functionality of the application. So these are the 5 initial requirements which define the scope of our application. I don't want to go in details because these are the requirements we finalized after doing the scope analysis for the employee pension scheme. So if you take a look at the screen, you can understand the whole functionality. If I can just read out aloud. Like here, the requirements include the which to onboard the new employees to the pension plan and capture the employee information. Also, the system should allocate fund into it should allow administrator and employees their current and past fund balances. It should also allow employees to admin to record their month-end returns for the various asset type and incorporate these returns into the employee balance fund. And at the end, it should display employee specific and overall dashboard. So whatever the responses that we have received, these are our observations, which are related to each for each. Like in a requirement specification, we observe that generated requirement specification are largely provided requirements in align with the provided business requirements, which means that the consistency is maintained. Next, the generated rules and processes were also satisfactory, which provided high-level details at some point, but we handle it by providing edit prompts and also manually the details that were missing. In the design specification, we first observed that the description for entities and relationship is generated, also maintaining the consistency throughout. The generated services are mostly the textual description of those services, which cover the method signature along with its input and output data type. Within the screen description that were not satisfactory because at first it generated 7 screens which were not actually covering the or not addressing all the business requirements that we have provided initially. So here we observe that the context is not retained, or we can say that context formatting is observed here. So we provided another edit prompt to with a high level specification, screen specification that we have generated, and then it was able to generate the desired screen descriptions. The screen description included screen layouts, screen structure, field behavior, and were mostly in alignment with the application requirement. Uh, these are few observations related to generated code. The code generated for UI layer was like a lot of edits here. So here you can see that HTML code was largely as per screen specification. For CSS, it is observed so that to integrate the CSS and prompting it to generate, and because that is not what we have expected. Next, some were observed in resizing and positioning those UI components. So that's also we manually did. Few code correction related errors and missing imports we resolved manually in UI layer. In service layer, it is observed that it was able to generate the basic CRUD functionality. Like it was able to generate the services of service or related operations for create, read, delete, and update. Sorry. And for the rest of methods, which include the business logic, it was somehow unable to generate the business logic. So we preferred to write it manually, and it was able to generate the code specific to it was able to generate the queries, but code related to database connectivity was manually written. And also multiple instances of a compilation error as well as a mismatch in input is observed. And for test case generation, it actually did well. It generated various test cases covering the scenarios like a positive, negative test cases, considering the data accuracy and screen navigation.
What percent of it was correct?
Yes, actually, I'm going to explain it in upcoming slides. So these are the screenshot of generated application. These are simply 5 sample screenshot which I have shown here. Application is big enough. So overall, if you look at the first table, it depicts the prompts and prompt and effort summary, where the T depicts the template prompt that we have defined in our generic prompt template, and edit prompts are the number of edit prompts that we have to give whenever the inaccuracy or incorrect responses were generated by LLM, and we have to give another prompt to make it correct. So this is the count of that E stands for edit prompt. Here I have mentioned the edit prompts for each phase, required edit prompts. Like for requirement specification, we required 1 edit prompt. Similarly, for other phases as well, some edit prompts were required, and in total we required total 76 prompts, and effort was observed of 22%. Overall productivity gain was 70.66% is observed. The second table shown on the right side, it actually depicts the overall scope of the application. If you look at the generated artifact count, you can see the number of processes generated, number of correct processes I would say, because we calculated it for the generated responses, generated correct responses. So these are the number of artifacts that we have generated. At the end, I would like to highlight some lesson learned after in this experiment. I would like to say that the quality of response is actually dependent upon the quality of prompt that you are going to give to LLM. So this is one of the major observation I would say. And the second point is that the approach that we use for breaking down our application into a smaller function really work well, because it is easy to remember the context if we break down our functionality, and will not suffer from the context forgetting problem, which we usually observe in LLMs. Third point, I would say, generative AI based code generation is not actually as effective as a model driven engineering. So especially for the large application, we tried it for small application, but it might get complex, or it might get difficult to generate a code for a large application if our scope is big. And for the requirement specification and test cases, the responses generated were satisfactory, but for code generation and design specification, it is observed that the models struggle a bit. And at last, in future, we are planning to combine this MD with generative AI to leverage the benefit of both. Also, we are planning to use the contextual prompts, and generative AI are also trying to populate the design model based on that. We have used this waterfall approach in our prompting technique that I have explained. But in future, we would like to give a shot to try agile as well. And also, this case study is evaluated and validated on one single LM, that is ChatGPT, and evaluated on small yet complex enough application. But we would like to try for the other LLMs, and also we'll try to evaluate other domains as well. I think that's it from my end. Thank you for your attention, and if you have any questions, you may ask. Yes, please.
So you have mentioned that to decrease the manual copy paste process, you have done it in a single
Right.
code generation.
Right.
So is that the case? Due to that, it will be difficult to manually edit the incorrect or inaccurate things what you got in the code, right? So you have around 14 edit prompts which you did in the source code. So
Right.
is it because of you created it in a single file, or if you have divided into multiple files, would have changed the number of edit prompts you have done?
Actually, the division, if you look at it now, let me show you the prompt template of code generation first. Okay, so this is the template prompt. Here, if you look at this, the structure, we first generated service class code. Basically, our application is designed using MVC architecture. So we are going to have a model, view, and controller sort of thing. So the service class is going to include all the business logic and functionality that define the operation and service. In data access object, we are going to have all the database related activities, which include like create, update, delete. Input output class is more like a getter setter. It just represent the entity. So that's why we propose the approach to separate it into the single file, so that these like dependency, there is interdependency between these three classes. So model is able to understand this dependency because of this structure, that this class is going to create a constructor of this class and going to create object of this class. So this dependency becomes more clear if we provide a structure to our code, and that's the aim of dividing it and generating it into the single file, actually.
And were the edit prompts and all specific to anything, or were they also generic?
No, edit prompts are specific. You have to observe the generated response first, and according to that, you have to give the edit prompts. If edit prompt is related to missing details, then it might be preferable to provide those missing details within edit prompt itself, so that model is able to generate more correct response. Yeah, thank you. Yeah, yes.
A lot of your later stage realizations will depend on what you started with. So in this case, you started with a meta model, right?
Yes.
Did you by any chance actually check the completeness and correctness of the meta model itself, and how did you do that?
Actually, I think the answer to your question can be my second author, our lead.
Okay.
Better.
Yeah, actually, there has been a lot of effort has gone in terms of understanding what requirement meta model should have, what design specification should have, what code generation should have. Okay, what meta model that we have shown is just a high level glimpse of those aspects. Real meta model could be very big. Okay, we come from the model driven engineering group, so we believe we understand meta a bit better. Okay, so from requirement perspective, focus was more on any business application. Basically, it's just nothing but you automate set of processes. Okay, so requirement part covered that processes, activities, rules, that aspect. Okay, and in design part, we focus more on the design aspect, like what could be the high level services, what could be the high level screens, what could be the data model. So those key element we covered in the design meta model. And on code, you could see in the code we haven't considered the deep detail of what could be the screen implementations. So at a screen level, we just stopped at the code level, we just stopped at the high level class model. That's, there is a classes, operations, and parameter, the MVC part that she mentioned. So we just cover only that part, and we rely upon on LLM to understand. She has also shown the code generation template wherein technology stack was given as input. Okay, so there we relied on the LLM to understand the technology and the high level specifications that we have given, that what are the screen specification, what are the design specification. That's how the overall approach has been, on the perspective of we will be doing a successive refinement from requirement till the code generation. So to some extent we rely upon LLM to understand those concepts, and there was of course lot of revision went into understanding what exactly LLM is, whether it's able to understand these labels that we are having in the meta model or not.
So,
I
so
hope I could answer your
yeah,
question.
yeah. So you would say this was more like a minimalistic meta model that is necessary to get your process going.
Yes, you can say like that. Yeah.